Hello, everybody. My name is Mohsen, a former computer engineering student, and currently I'm a software engineer trying to combine the power of AI and software engineering to build scalable and production-ready AI services. Today, I'm going to explain you the concept of AutoGrad, but before this, let me give you a little recap. You probably know the general concept of neural networks and how it can be modeled to a lower level representation called computational graph. And you also know with this fact that we need two passes, forward pass and backward pass. We need forward pass to compute the loss value at each iteration of gradient descent, and the backward pass to compute the gradients of our neural networks to update the weights and trainable parameters to reach to a local or hopefully a global minimum. But there is a clever question here. Is there any systematic way for us to define only the architecture of our neural network and its forward pass and delegate the backward pass implementation to our deep learning framework engine? Well, the answer is yes, and this is where the concept of AutoGrad comes into play. Thanks to this concept, we can just define our neural network architectures, its input, output, or immediate layers, and how they can connect to each other. And we also need to define our forward pass, and thirdly, we need to determine our trainable parameters, and we'll see how it can be simple. And that's it. The backward pass, the gradient computation will be systematically handled by the PyTorch AutoGrad. Let me show it to you with a simple example. You can see this neural network. Actually, it's a computational graph, and we want to implement it in this class called simple graph. Well, we have this constructor. We take a weight and bias and wrap it through a PyTorch tensor. And here we want to implement its forward pass. And from the picture, you can implement it as simply as possible, such this. First, the tanh weights times your input plus your bias. And that's it. And we also need to, define our loss function. And we use L2 loss to have it simple as possible, which will be like this: y true minus y prediction times 2. So let me run this code snippet and show the results to you. As you can see, we create an instance from our class, and then we call our forward pass over this variable feature, which is a tensor, as our input to the neural networks. And then we compute the loss from our target and the output of neural network. And as you can see, for input 1 and target 7, we have this prediction, this output, which is 0, and the difference between 7 and 0 squares 2, which will be 49, which is correct. But the main point in this implementation here in this place, that this parameter requires grad equals true. By determining or by setting these parameters to your these parameters, weight and bias, you tell PyTorch engine to calculate the gradients for backward pass, and that's it. You do not need to know the details of implementations for backward pass, and this is the power of PyTorch AutoGrad.